All right, geometry. So here's our first question from Delta Math. It says, drag the yellow point until an accurate height of the triangle is drawn. Afterwards, fill out the empty boxes below to determine the area of the triangle. So notice that this is the yellow dot we can move. So they want this 5.4 to be the base of our triangle. Now understand that any side of the triangle can be the base. All right, we could always rotate it so it's at the bottom. Okay, but 5.4 is going to be our base. So that means that this dotted line coming from this opposite vertex right here where the blue dotted line stops has to be perpendicular to this bottom side 5.4. So notice that this is not perpendicular. It doesn't make a right angle. So I'm going to click and drag this point. And now because this triangle is obtuse, notice what happens once I get here. That's still not a right angle. So I have to actually go outside of the triangle until boom, there is your right angle. And this is just emphasize that the height has to be perpendicular to the base. So now in this picture here, once I've done that correctly, you got the right angle. Now they're going to ask me for the length of the base. Now this base is 5.4. Now I know we extended it beyond here, but we still just use the side of the triangle 5.4. The height of my triangle is this blue dotted 3.3. And to find the area of the triangle, I do 5.4 times 3.3 times a half. And they did it for me. It's 8.91. And I believe I'm correct. Boom. Now, not all triangles are obtuse in nature. So sometimes the height will be in the triangle. But for this one, you had to go outside the triangle. All right, next problem's coming. Okay, so here is a triangle on the coordinate plane, triangle OPQ, with vertices at O, -6, -8, which they graphed, P at -4, -2, and Q at -9, -3. It's drawn. What is the area of the triangle? So one of the clever ways that they think you should do is they think that you should create a rectangle around this triangle. And I'm going to do so with my pen. So watch what I do. I'm going to draw a dotted segment from Q down to O, to the right to O. And what I've done is I've just created a right triangle. I'm going to go over to where P is, and then up to P. And I create another right triangle, and then from P over to where Q is, and down to where Q is. And I created another right triangle. I have 1, 2, 3 right triangles, and I have a rectangle. I think I can find the area of the rectangle, and then I can subtract away the areas of the 3 right triangles, and that'll leave me with this area left over. And that's what I'm going to do. Okay, so let's first find the area of the rectangle. So I'll be organized here. So area of the rectangle. That's just base times height. So the base here, 1, 2, 3, 4 is 5 across. The height here, 1, 2, 3, 4, 5, 6 up. So 5 times 6, that's 30. So that is the area of the rectangle. That would be units squared. So now let's call this triangle 1, this triangle 2, and this triangle 3. All right, so let's find the area of triangle 1. Sorry about my marker. Maybe I'm going too fast. 1/2 base times height. So in this triangle 1, let's use a different color. Let's use red for these triangles. The base is 1, 2, 3. The height is 1, 2, 3, 4. And I stop at Q, 5. So that's 1/2 times 3 times 5. That's half of 15. Half of 15 is 7.5. And that'd be units squared. I'm not going to keep writing it. Okay, now let's find the area of triangle 2. That's going to be 1/2, again, base times height. So the base here is 1, 2, and the height is 6. It's the same 6 as the rectangle all the way up to P. So 2 times 6, that's half of 12, which is 6. And then the area of the third triangle at the top, I need to do 1/2 the base. Let's call this top side the base. 1, 2, 3, 4, 5. Let's call this the height, and that's a height of 1. So half of 5 times 1, that'd be half of 5, which is 2.5. If we add up these three red regions, which we're going to end up subtracting away. 7.5 and 2.5 is 10, plus 6 is 16. So now to find the area of my blue triangle, what I want, so the area of triangle OPQ, I'm going to take 30, which was the area of the rectangle, and I'm going to subtract 16. And I get a nice even 14, and that would be in units squared. So it's kind of a lengthier problem, but I really like it. This is really the first time I saw this on a coordinate plane. I think it's really inventive. Okay, so hopefully you get what we just did. All right, so 14 is my answer. Let me plug it in and cross my fingers, right? Oh yeah, and we're right. Love it. So see how they created the triangles, and they did the three triangles and then subtracted it from the rectangle. Perfect. Awesome. All right, next problem's coming. Okay, so this is a circumference question. It says the radius of a circle is 5 inches. Find its circumference in terms of pi. The reason I wanted to show you this one is because of these words in terms of pi, okay? So we should know that the circumference formula is either pi times diameter or 2 pi r, which is what I like to remember. They give us the radius. The radius is 5, so the circumference is just 2 pi times 5. So when it says leave it in terms of pi, you could type it into the graphing calculator, like 2 times pi times 5, and get a decimal answer. They don't want that, though. They want it in terms of pi. So forget the pi is there. Just multiply 2 and 5. That's 10. And then bring the pi down. And that would be the answer, 10 pi, and the label would be inches, just like it is there. So in this box, notice they have the pi symbol down there. You're going to type in 10 and then press the pi button next to it. 10, then pi. And that's our answer, I hope. Sweet. Okay, I'm going to make a second video for the next two problems.